It stands in a deep canyon of the Colorado River, a massive curving wall of concrete holding back one of the largest reservoirs in the country. Glen Canyon Dam is a monument to human engineering, a colossal structure that tamed a wild river and created Lake Powell, storing an immense quantity of water for the benefit of the entire region. Millions upon millions of people depend on it, for water, for electricity, for the management of the river that sustains the desert Southwest. But behind that wall sits an almost unimaginable volume of water, held in check by the dam, and that leads to a question that is terrifying to contemplate. What would happen if Glen Canyon Dam gave way? If that great wall failed and the water it holds was suddenly released, a wall of water would surge down the canyon and the communities in its path would face catastrophe. If Glen Canyon Dam gives way, some towns go under first, and understanding which ones would face the water and why reveals the awesome and sobering power held in check behind that towering wall of concrete. Before we go any further, it is important to be honest and clear about something crucial. Glen Canyon Dam is a robust and carefully engineered structure, monitored and maintained with great care, and the catastrophic sudden failure of the dam is considered highly unlikely. This is not a prediction that the dam will fail, nor a suggestion that its failure is imminent or probable. Rather, it is an exploration of a hypothetical scenario, a thought experiment that helps us understand the immense power held behind the dam and the geography of the river and the communities below it. With that important caveat firmly in mind, let us explore what the consequences of such a failure would be, and which communities would be first in the path of the flood. Understanding the scenario is valuable not because the failure is likely, but because it reveals the stakes involved in the great structure and the importance of the care that keeps it safe. In this video, we are going to explore this hypothetical scenario in full, always keeping in mind that it is a thought experiment rather than a prediction. We are going to understand the sheer scale of the water held behind the dam and the energy it represents. We are going to imagine how the flood would behave as it surged down the canyon and follow its path to identify which towns and communities would go under first. We are going to uncover the alarming possibility of a cascading failure down the chain of dams on the river, and what that would mean for the communities far downstream. We are going to consider what makes a dam failure flood so uniquely dangerous, and the regional catastrophe that would extend far beyond the immediate inundation. And we are going to return again and again to the reassuring reality that the failure of Glen Canyon Dam is considered highly unlikely, and to the lessons that imagining the scenario can teach us about the power of the water and the importance of the dam's safety. Stay with us, because understanding the power held behind this great wall of concrete is a way of appreciating both the awesome forces the dam controls and the remarkable engineering that holds them safely in check. To understand the scenario, you first have to understand the scale of what the dam holds back. Behind Glen Canyon Dam lies Lake Powell, one of the two largest reservoirs in the country, an enormous body of water stored in the canyons of the Colorado. When full, this reservoir holds a truly colossal quantity of water, an amount so vast that it is difficult to comprehend, enough to cover an enormous area to a great depth. This water is held in place by the dam, kept from flowing freely down the river, stored and controlled for the benefit of the region. The purpose of the dam is precisely to hold this water back, to capture it and store it and release it in a controlled way. But the very act of holding back so much water creates a potential energy of staggering proportions, a vast reservoir poised above the river valley below. It is this stored water and the energy it represents that would be unleashed in the event of a failure. If the dam were to fail catastrophically, that immense quantity of stored water would be released, surging down the canyon below with tremendous force. This would not be a gradual rise, but a sudden, violent flood, a wall of water racing downstream, carrying with it enormous energy and destructive power. The initial surge, close to the dam, would be the most violent, a torrent of water tearing through the canyon, and as it moved downstream, it would continue to carry great force even as it spread and moderated. The flood would travel down the river, following the path that the Colorado takes on its journey through the canyon country and toward the reservoirs and communities downstream. To understand which towns would go under first, you have to follow the river downstream from the dam and see which communities and areas lie in the path of the flood. The river immediately below Glen Canyon Dam flows into some of the most spectacular and rugged canyon country in the world, a landscape of deep gorges and towering walls, and this geography shapes the way the flood would unfold. In the reaches just below the dam, the river runs through a deep canyon, and the first areas in the path of the flood would be those within this canyon corridor, the places where people are present in the canyon, along the river, in the areas that the surging water would reach. These are not large towns in the ordinary sense, but the communities and the gathering places within the canyon country, the areas where people live, work, and visit along the river below the dam. And they would be the first to face the flood, receiving the surge while it was still near its most violent, with the least warning times. For these areas closest to the dam, the flood would arrive quickly and with tremendous force, making them the most immediately and severely threatened. The canyon corridor below the dam is a place of extraordinary beauty and also of particular vulnerability because the people who are present there, along the river, in the depths of the canyon, would have little time and little means of escape if the flood came. The very features that make the canyon so spectacular, its depth and its ruggedness and its remoteness, are the same features that would make it so dangerous in the event of a flood, because the water would be channeled and concentrated by the canyon walls, surging through the narrow corridor with tremendous force, and the people within the canyon would have few options for reaching safety. The areas within the canyon corridor below the dam, then, would be among the first and most severely affected by a failure, the places where the flood would strike first, and where escape would be most difficult. As the flood continued downstream, it would travel through the canyon country toward the next great feature of the river system, the reservoir downstream that receives the water of the Colorado after it passes through the canyons. This is a crucial point in understanding the scenario, because the flood from Glen Canyon Dam would ultimately reach the next reservoir downstream, and the arrival of such an enormous surge of water at that reservoir would have profound consequences. The reservoir downstream, itself held back by another great dam, would receive the flood, and the sudden arrival of so much water could threaten that dam as well, raising the specter of a cascading failure in which the flood from one dam threatens the next. This is one of the most alarming aspects of the scenario, the possibility that the failure of the upstream dam could cascade down the river system, threatening the dams and the reservoirs and the communities downstream in a chain of catastrophe. The communities that lie below the downstream reservoir and its dam would be the next to face the danger in the scenario where the flood cascaded down the system. Below that reservoir, along the lower reaches of the river, lie a number of communities that have grown up beside the water, towns and cities in the river valley, that depend on the river, and that would be in the path of the flood if it continued downstream. These communities, in the lower river valley, would face the danger if the cascading flood reached them, the surging water threatening the towns and the people along the lower river. The flood, having traveled a great distance from the original dam, and potentially having been augmented by the failure of the downstream dam, would still carry enormous destructive power, and the communities in the lower river valley would be in grave danger. Let us consider more specifically the towns that would be threatened in the lower reaches of the river, in the scenario where the flood cascaded down the system. Along the lower Colorado, below the great reservoirs, lie a series of communities that have grown up beside the river, drawn by the water and the opportunities it provides. There are the towns near the river just below the lower dam, the communities that sit closest to the water in the reaches below the reservoir, which would be among the first in the lower valley to face the flood. There are the cities and towns further down the river, situated in the valley through which the Colorado flows on its way south, which would face the flood as it continued downstream. And there are the communities in the lower reaches of the river, in the areas closer to where the river approaches its lower course, which would be threatened as the flood traveled the length of the valley. These communities, spread along the lower river, would be the towns that go under in the lower valley if the flood cascaded down the system, arranged in sequence as the water traveled downstream. The towns closest to the dams and the reservoirs would face the flood first, and most violently, with the least warning, while the more distant communities would face a flood that had spread and moderated somewhat, but that would still be enormously destructive, with more warning time, but still in grave danger, the way that the flood would travel down the river system, threatening first the canyon corridor below Glen Canyon Dam, then potentially cascading to threaten the downstream reservoir and its dam, and then the communities in the lower river valley, in sequence as the water made its way downstream. The towns that would go under first are those closest to the dam and in the canyon corridor, followed by the communities downstream, in an order determined by their position along the river. It is worth understanding how the flood would behave as it traveled through the canyon, because the geography would shape the disaster in dramatic ways. When a great volume of water is released into a deep, narrow canyon, the canyon walls channel and concentrate the flow, so that instead of spreading out as it would on an open plain, the water is confined and driven forward with tremendous force and height. In the narrow reaches of the canyon, the flood could rise to enormous heights against the walls, surging through the gorge as a towering wall of water its power magnified by the confinement of the canyon. This is one of the reasons the canyon corridor below the dam would be so dangerous, because the very geography that makes the canyon so spectacular would also concentrate the flood into a surge of extraordinary height and force, leaving little chance of escape for anyone within the canyon's depth. The behavior of the flood in the canyon is a crucial part of understanding why the areas closest to the dam would be so severely and immediately threatened. There is a crucial element of timing and warning in the scenario, because the fate of the communities in the path would depend enormously on how quickly they could be alerted and how much time they had to reach safety. For the areas within the canyon corridor closest to the dam, the flood would arrive almost immediately, leaving essentially no time to react, and the people there would be in the gravest danger. For the communities further downstream, in the lower river valley, there could be more time, a span of hours between the failure and the arrival of the flood, as the water traveled the great distance down the river system. This time is precious, and it is the reason that warning systems and the ability to detect a failure and alert the population quickly could make such a difference for the more distant communities, potentially allowing them to evacuate before the flood arrived. But the challenge of warning and evacuating a large population in the limited time available would be immense, and the effectiveness of the response would depend on the systems in place to detect the failure and to warn the people in its path. The geography of time, in other words, would shape the disaster as much as the geography of the river. There is a natural question about what could even cause such a failure, given how robust the dam is, and understanding this helps to keep the scenario in perspective. In general, dams can fail through a few basic mechanisms, such as being overtopped by more water than they can handle, or through the gradual weakening of the structure or its foundation, or through some catastrophic external event. But it is precisely against these mechanisms that Glen Canyon Dam is defended. It is a massive structure designed to resist the enormous pressure of the water it holds, equipped with means to release water in a controlled way and monitored constantly for any sign of weakness or distress. The very mechanisms that cause dams to fail are the ones that the design and the maintenance of the dam are intended to guard against, which is a large part of why its catastrophic failure is considered so improbable. Understanding this helps to keep the scenario in perspective, as an exploration of consequences rather than a realistic expectation, and it underscores the care that has gone into making the dam as safe as it is. It is worth pausing to reflect on the nature of the danger a dam failure flood would represent, because it is different in important ways from an ordinary flood. An ordinary flood, caused by rain or snowmelt, typically rises gradually, giving people time to prepare and to evacuate. But a dam failure flood is sudden and violent, a wall of water released all at once, arriving with tremendous force and speed. This suddenness is what makes a dam failure flood so dangerous, because the time to escape may be very short, especially for the communities closest to the dam and within the canyon corridor. The flood would arrive not as a gradually rising river, but as a surging torrent, carrying debris and moving with great energy, capable of sweeping away everything in its path. The destructive power of such a flood and the limited warning time are what make the dam failure scenario so catastrophic to contemplate. The consequences of such a failure would extend far beyond the immediate inundation of the communities in the path, because the release of the reservoir would have profound effects on the entire region. The water supply that the reservoir provides to millions of people would be disrupted. The electricity generated at the dam would be lost, and the management of the river would be thrown into chaos. The cascading threat to the downstream dam and reservoir would compound the catastrophe, potentially disrupting the entire system that manages the Colorado River and on which the desert Southwest depends. The economic damage would be immense, the destruction of communities and infrastructure staggering, and the disruption to the region's water and power systems profound. The failure of Glen Canyon Dam would be not just a flood, but a regional catastrophe, affecting far more than the communities directly in the path of the water. This brings us back to the reassuring reality that must be emphasized, which is that the catastrophic failure of Glen Canyon Dam is considered highly unlikely. The dam is a robust structure, built to a high standard, and it is monitored and maintained with great care. The engineers who designed it accounted for the enormous forces it must withstand, and the structure has proven its durability over a long span of time. The scenario we have explored is a hypothetical one, a thought experiment that helps us understand the power held behind the dam and the geography of the river below, not a prediction of an event that is expected to occur. It is important to hold both of these truths together, the awesome potential danger represented by the immense reservoir, and the reassuring reality that the dam is very unlikely to fail. The exploration of the failure scenario is valuable for understanding, but it should not be a source of undue fear because the dam is, by design and by careful maintenance, a very safe structure. Still, the exercise of imagining the failure serves an important purpose because it reveals the immense responsibility that comes with holding back so much water, and the importance of the ongoing care and vigilance that keep the dam safe. A structure that holds back so vast a reservoir, poised above communities and canyon country below, carries an enormous responsibility, and the safety of the people downstream depends on the continued integrity of the dam and the diligence of those who monitor and maintain it. The failure scenario underscores why that vigilance is so important, why the resources devoted to the safety of the dam are so well spent, and why the ongoing monitoring and maintenance must never be neglected. The very fact that the failure would be so catastrophic is the reason that so much care is taken to ensure it never happens, and the imagining of the disaster is a reminder of the stakes involved in keeping the Great Dam safe. The scenario also illuminates the interconnected and cascading nature of the Great Dam system on the Colorado, the way that the dams and reservoirs are linked in a chain down the river, so that the failure of one could threaten the others. This is one of the most important insights that the scenario reveals, the way that the great structures on the river are not isolated but connected, each holding back its reservoir, but each also dependent on the ones upstream, so that a catastrophic failure could cascade down the system. This cascading danger is a reminder of the importance of the safety of the entire system, of all the dams that manage the river, because the failure of any one of them could threaten the others in a chain of catastrophe. The safety of the whole system depends on the safety of each of its parts, and the cascading scenario underscores the importance of maintaining and monitoring all of the great dams that hold back the waters of the Colorado. There is also a lesson here about the communities that live below the great dams, and the relationship of benefit and risk that they have with the structures that provide so much and hold back so much. The dams provide enormous benefits, the water and the power and the management of the river that make life in the region possible, and the communities have grown up beside the river and below the dams to enjoy those benefits. But the same structures that provide the benefits also hold back the water, and in doing so, they create a potential danger, the possibility, however remote, of a catastrophic release. This duality of benefit and risk is inherent in the great dams, and it is a reminder that the infrastructure on which we depend carries responsibilities and hazards as well as advantages. The communities below Glen Canyon Dam live with both the benefits and the theoretical risk, and while the risk is very small, its potential magnitude is a reminder of the power held in check by the structures we build. There is also the important matter of preparedness, even for events that are highly unlikely, because the communities in the path of a potential dam failure flood benefit from planning and preparedness. Emergency plans, evacuation routes, and warning systems, even for an event as improbable as a dam failure, are a wise investment, because the very rarity of such events means that people may be caught unaware if they are not prepared, and the consequences would be so severe that even a small probability warrants attention. The planning for a dam failure scenario is part of the broader emergency preparedness of the region, a recognition that even the most unlikely disasters warrant some level of readiness for the communities in the canyon corridor and along the river. Being aware of the potential danger and having plans in place, however unlikely the event, is part of living responsibly below a great dam. In the end, the question of which towns would go under first if Glen Canyon Dam gave way is a way of understanding the immense power held behind the dam and the geography of the river and the communities below it. The areas we have followed down the river, from the canyon corridor closest to the dam, to the communities in the lower valley that would be threatened if the flood cascaded down the system, are the ones that lie in the path of the water, the ones that would face the flood in sequence as it traveled downstream. Their position along the river, the source of their connection to the water in normal times, would in the hypothetical scenario of a failure be the source of their peril. But it is essential to remember that this is a hypothetical, an exploration of a scenario that is highly unlikely to occur, undertaken to understand the power of the reservoir and the importance of the dam's safety, not to predict a disaster. And so, as we contemplate the awesome quantity of water held behind that great wall of concrete, and imagine the flood that would follow its release, we should come away not with fear but with a deeper appreciation for the engineering that holds the water safely in check, for the vigilance that keeps the dam sound, and for the immense power of the river that the dam controls. The towns and areas in the path are a reminder of the stakes, of what is held back by the dam and what depends on its integrity, but they are also a reminder of the value of the careful work that keeps the dam safe and the communities below it secure. The failure of Glen Canyon Dam is a scenario worth understanding, but it is one that the diligence and the engineering of those who built and maintained the dam have worked to ensure remains firmly in the realm of the hypothetical, a thought experiment rather than a prophecy. The story of Glen Canyon Dam and the scenario of its failure is finally a story about the relationship between human beings and the great forces of nature that we seek to control, about the way that we build enormous structures to tame the rivers and store the water, and about the responsibilities and the risks that come with holding back so much power. The dam stands, the water is held, and the communities below live in safety. And that is a testament to the human capacity to control the mighty forces of nature and to hold back safely and enduringly the immense reservoir that gives the region its life. The scenario of the failure is a reminder of the power that is held in check and the importance of the care that keeps it contained, a way of appreciating both the magnitude of what the dam holds back and the achievement of holding it back safely. The towns that would go under first are a reminder of the stakes and a testament to the importance of the vigilance that ensures they never do. As we reflect on the scenario, it is worth remembering that the great dams of the Colorado, including Glen Canyon Dam, have stood for a long time, holding back their reservoirs, providing their benefits, and keeping the communities below them safe. The engineering that created them was a remarkable achievement, and the ongoing care that maintains them is a continuing responsibility, one that is taken seriously by those charged with the safety of the dams and the people who depend on them. The scenario of a failure, terrifying as it is to contemplate, is a reminder of why that care is so important and of the stakes involved in the safety of the great structures. It is a scenario that we explore not to frighten, but to understand. And understanding it deepens our appreciation for the engineering and the vigilance that keep the water safely contained and the communities below the dam secure, so that the flood we have imagined remains forever a thought experiment and never becomes a reality. The immense reservoir behind Glen Canyon Dam and the towns and canyon country below it together tell a story of power and responsibility, of the enormous forces that the dam holds in check, and the communities whose safety depends on it. The scenario of the failure is a way of grasping the magnitude of that power and the importance of that responsibility, a reminder of what is at stake and why the safety of the dam matters so much. And it ends as it should, with the reassurance that the dam is safe, that the failure is highly unlikely, and that the communities below it can continue to live in the security that the careful engineering and the ongoing vigilance provide. The towns that would go under first will, if the care continues and the vigilance holds, never go under at all, and the flood we have imagined will remain a scenario to be understood rather than a catastrophe to be endured. That is the hope and the expectation, grounded in the engineering and the maintenance, that keep the great dam safe, and it is the note on which the story of